Okay, so today we're starting trigonometry part 2. And what I will be doing in the next couple of videos, I will be breaking up all the topics that we will be covering over, the next couple of videos. So it might be between 3 to 4 videos. And essentially a quick overview of what we will be discussing. One, periodic functions. So we're going to talk about, well, what are periodic functions? What characteristics and properties do they have? What is a sinusoidal function? Elements of sinusoidal function. So in this part of trigonometry, we're actually going to learn what a sinusoidal function is and how to sketch them. So we're going to learn how to sketch y equals sine x, y equals cos x, how to apply transformations to them. And then we're going to take it up a notch and we're going to learn how to sketch the graph of y equals tan x and all of the primary trig functions reciprocal graphs as well. So we're going to learn cosecant, secant, and cotangent. In addition to that, we're going to learn how to do and apply transformations to those graphs. And I ran out of space at the very end, but once we talk about all these several different topics, we're going to then compile that together and apply that to several trigonometry word problems. So we're going to first start off with what is a periodic. Okay, so what I've drawn here are two different examples of what a periodic function is. Now, when we think of the word periodic, I want you to think of the word repetition, repeat. Okay, so that's going to be the buzzword for periodic functions. So we're looking for a pattern that repeats over and over again over a set interval. Now, if we look at the first example, notice that we start here at 0 and negative 2. And then when we shift over 1 unit to the right, it goes up to 0, back down to negative 1, and then back up to 0, and then back down to negative 2. So I'm going to stop that for a second and just put a little line, a dashed line, between 1 to 4. Now, if you notice, it repeats that exact same pattern. We actually kind of create a shape that looks like an M. And notice that it repeats itself over the exact same interval of 4 units. The distance between 4 and 8 is 4. And the distance between 0 and 4 is also 4. And if I were to cut a line through my dashed lines right there, I could literally pick up that M and put it right on top of the other M by just shifting it over to the right. So that's a sign that example A is in fact a periodic function because it repeats over and over again over the same interval. So it repeats over the same interval. Now if we look at the second example, well, it's very similar. I start at 0, I move up to a maximum of 1, come back down to 0, and then go to negative 1, and then I come back to my original starting point, which is 0. And then it appears that it repeats that same process again. Goes up to a max, 0, min, and back to 0 again. So we could say that we actually complete one period between 0 and 4 seconds. And again, our period is a length of 4 units. And again, if I lift up the two dotted dash lines that I've recreated on the second graph, lift it and shift it to the right, it would overlap it right on top. So again, B is also a periodic function. Now, there is a difference between A and B. These are both perfect examples of what a periodic function is. But notice that in the first example, we have nice, sharp edges. And in the second graph, we have a nice wave-like shape. When we have a function, when it's graphed, it's periodic, and it has a wave-like shape to it, we have a special name for that, and that's called a sinusoidal function. So it's a periodic function with a wave-like shape. And the rest of this unit is going to talk about actually sketching sinusoidal functions. And so it's very, very, very critical that when you're piecing together all your information and sketching your graph, that you do not draw sharp lines and edges to your graph. It must look like a curve-like shape. I've seen a lot of students lose marks for not making sure that it's a wave-like shape. So that's a key component to sketching sinusoidal graphs. Okay, so now we're going to take a look at examples of functions that are not periodic. So let's say we have the following graph. And this is 1, 2, 3, 4, 5. Let's extend this down a bit. Okay. Let's say that I have a graph and it looks something like this. Well, this is clearly not a periodic function because it's not repeating any pattern. As you can see, the graph is actually increasing over time. It increases, takes a dip, increases, takes a dip, it increases, takes a dip, and so on and so forth. If I were to draw dotted lines over the first period and chop it off there and shift it directly to the right, it would not overlap on top of this line here. So this is not a periodic function. Okay? Now, a key thing to notice is that a periodic function is not always a sinusoidal function. However, a sinusoidal function is always a periodic function. Okay, and just to reiterate that concept, the reason why a sinusoidal function is always going to be periodic is because it repeats over the same interval. The only reason why we call this periodic function sinusoidal is just the way that the graph is sketched. The fact that there are no sharp edges and it's just a curve. Okay? So that essentially summarizes what a periodic function is and how to distinguish it between a sinusoidal function. Okay? So in the next video, we're going to talk about the elements of a sinusoidal function. I hope this video helps, and please subscribe to this video if you'd like to see some nice more math videos. Until next time.